is called equi partition law or equipartition theorem. Okay, it is called equipartition law or equipartition theorem, right? So what is this thing? What is equipartition law or equipartition theorem? First of all, let's attack this word equipartition. Equi means equal. Now table puru have. Okay, fine, we have started new topic, right? You can end the table over there, no problem. So equi means equal and partition means divided or distributed, correct? Okay, so what is equally divided? That is what we are going to figure out. You see, now if I want to write, listen to this carefully, if I want to write, let's say in a monoatomic molecule, example થી start કરું એનાથી એકદમ જલ્દી concept grasp થઈ. Suppose we talk about monoatomic molecule. It has 3 degrees of freedom, isn't it? Right? And those 3 degrees of freedom are for Vx, Vy and Vz. Basically, we are talking about half m Vx square, half m Vy square and half m Vz square. Now, do you remember that earlier I did explain that because of the random behavior or random motion of all the molecules, right? It is that when we take the average of Vx square, Vy square and that of Vz square, these averages are equal. Do you remember that? Do you remember this one, everybody? Okay. So now what that means is, if I will take the average kinetic energy of a molecule, average kinetic energy of a molecule, translational kinetic energy, monoatomic ની જ વાત ચાલે છે. I'm explaining this concept using monoatomic because it's very intuitive or easy to understand, right? So now, do you realize that when we take average, then the average of this, this and this will be equal? Yes or no? Why is it equal? Again, there is no preferred direction. Just like the molecule could move in X, similarly it could move in Y or in Z also. So overall, when we take the average for the gas, yes, the 3 axes, their motions are independent. Not only that, there is no preferred direction. I hope you remember that. There is no preferred direction. X, Y, Z બધું same જ હોવું જોઈએ, right? So this is the idea of equipartition theorem. હવે આનો meaning શું થાય? Directly from this line, you can understand that on an average, the value of half mvx square, average, okay, so let me just, is equal to half mvy square for average and is equal to half mvz square for average. So again, what this means is this sentence, please note it carefully. It is that the energy of the molecule is equally distributed. A law નથી, law પછી લખાવી, but law is very close to this. The energy of the molecule is equally distributed on an average for every or for each degree of freedom. In other words, you can say that for each degree of freedom, the average energy is equal. Did you understand these two sentences? For each degree of freedom, the average energy is equal. રાઈટ. જો આમાં 3 ડિગ્રીઝ ઓફ ફ્રીડમ છે અને આ ત્રણેયની એવરેજ વેલ્યુ સેમ જ છે, આની એવરેજ લો, આની એવરેજ લો, આની એવરેજ લો, બધાની એવરેજ સેમ જ આવે. અંડરસ્ટુડ? That is what the sentence is, right? So you see, do you notice this thing now? Equally divided or equally distributed, right? Okay, so here is the equi partition law. હવે લખું છું officially, right? For a gas, the energy of the gas is equally divided or distributed the energy of the gas is equally divided or distributed for each degree of freedom available, right? The energy, sorry, the average, please write the average energy, excuse me, the average energy for each degree of freedom, the average energy for each degree of freedom for one molecule is 1/2 kBT. So this whole thing is the equipartition law. Okay, this whole thing is the equipartition law. Okay, now why is it half kBT? એ સમજાવું છું હમણાં. ઇક્વલ સુધી તો સમજ પડી ગઈ ને, that we are saying that for every degree of freedom the energy is equally distributed, right? જેમ આમાં ત્રણે ઇક્વલ આવે એવી રીતે. હવે હાફ કેબીટી કેવી રીતે આવે ને એ હમણાં સમજાવું. Did you write this? Okay, now how do we know it is half kBT? Right, let's try to understand that. So you try to recall, do you remember average translational kinetic energy for one molecule is 3/2 kBT? Do you remember this or not? Okay, હવે ઉપર શું લખ્યું? ઉપર એવું લખ્યું કે this is equal to half m vx square on average plus half m vy square average plus half m vz square average. I hope you got that. We took average, ત્રણેય ટર્મમાં average લઈ લીધી. So this is equal to 3/2 kBT. But we know that on an average all of these are equal, right? એ જ તો આ law છે. On an average these are all equal. Again they are equal because of the random motion. કારણ કે random motion થાય ત્યારે random motion માં એવું કઈ જોવે નહીં molecule કે આમ કરવાનું કે આમ. Suppose one was more, let's say this one was more, then we would say that x is preferred direction. Then you don't call it random. સમજાણું કે નહીં? Suppose this was more, then we would say that x is the preferred direction. That means it's not random anymore. Just like that, if this was more, we would say y is preferred direction, it's not random. So random ત્યારે જ કહેવાય કે જ્યારે બધી રીતે એમાં કઈ preference જ ન હોય. Okay, so that's why all the three are equal. Now if all the three are equal, I can easily write this as 3 times 1/2 mvx square on average. Is it okay? Left side clear? Apple plus apple plus apple, 3 apple equal to 3/2 kBT. Okay, what's cancelled now? 3 cancelled. ઓકે, હાફ મારે કેન્સલ કરવું નથી એટલે હું નથી કરતો. So I can say that half m vx square is equal to 1 by 2 kb, right? So half m vx square equal to 1 by 2 kbt. So what does this mean? It means that for this particular term, jo upar અહીંયા kt ની વેલ્યુ મેં કીધી, this term, this term, this term. So one particular term, how much is its value? We have got that one particular term's value is half kbt. So this is for only 1 degree of freedom, isn't it? Which 1 degree of freedom? Translation in x. આવી રીતે ટ્રાન્સલેશન ઇન y માં શું આવે? સમજ પડે છે? ટ્રાન્સલેશન ઇન y માટે એનર્જી શું આવશે? હાફ એમ વી વાય સ્ક્વેર ઓન એવરેજ ઇક્વલ ટુ 1 by 2 kbt. Did you understand this? Yes or no? હવે ઓલો સેન્ટેન્સ વાંચો. શું લખ્યું ઉપર? The average energy for each degree of freedom for one molecule, આ બધું one molecule માટે છે, is how much? 1 by 2 kbt for 1 degree of freedom. Remember, for each degree of freedom for one molecule the energy is 1 by 2 kbt. Clear? હવે તમને સમજ પડશે કે degrees of freedom શું કામ calculate કરી હતી એ હવે આવશે. Why did we worry about degrees of freedom? Okay, right? All this clear? Let's go to the next thing. હવે તમને familiar term આવે છે, stay tuned. Internal energy, right? You have studied a lot about this in chemistry, right? So what is internal energy? Well, definition is very simple. Energy of a system due to the random motion of its constituents or particles, due to its constituents or particles, is called internal energy, right? Is called internal energy. Again, this is the key word. Okay, now why is it called internal? કારણ કે એ અંદરથી જ ખબર પડે. What I mean to say is this internal energy cannot have a direct effect or cannot be measured from outside the system directly. Okay, let me give an analogy that will help you understand what is internal energy. Let's say that this is a road, okay, and on this road a bus is moving, right, with some speed, for example 10 meters per second, and the mass of everything inside the bus, including the wheels and everything, right, the whole bus, the body, the glasses, this, that, everything, okay. So suppose that mass is 1000 kg, 10,000 kg. So what will be the kinetic energy of the bus? We can easily say that it will be half into 10,000 into 10 square, isn't it? Right? But yes, we are assuming that, listen, we are assuming that this bus has windows, all right, but all the windows are pitch black, you can't see anything through it, you can't see inside. Okay, suppose you can't see inside the bus, right? So we are just seeing that there's a bus here and this bus is moving and it has this much kinetic energy and all that. Okay, fine, right? Now let's say that on the inside, you all would have gone for school picnics or such other tours with family or anything, and you would have noted that people don't sit quiet inside such vehicles during trips, right? Okay, people are doing all sorts of crazy things. So you are not seeing all that from outside, you understand? You can't see how people are moving inside the bus. Do you understand what I'm saying? You can't see how the people are moving inside the bus, right? Okay, now suppose, let's say that you could see inside the bus, and for that you might have to observe it from the inside, right? Suppose you are observing it from the inside, right? So you are going to see that some people in the bus are moving here and there, right? They are doing some sorts of random behavior. Okay, sometimes they will rotate. Okay, right? So all this exciting behavior we are only seeing from inside. So do you realize that when this person moves, for example, you compare two cases, everything just moving with the bus, no random motion, let's say, no random motion, and the other case is that inside the bus the people are moving here and there. Bus to bole move thati, but here the people are moving here and there. Do you realize these two cases are different? Okay, so that's the difference between this kind of kinetic energy that you are seeing from outside and internal energy. So if you go on the inside, you are going to be seeing that people inside this system or things inside this system, they are moving. Suppose આ move થાય, so એની પોતાની kinetic energy હશે કે નહીં? Does that make sense? So those energies are internal energy. Clear? That kind of energy is internal energy. Okay, and based on what we have studied earlier, suppose everyone is sitting idle, not moving at all, then do you realize in such a case we say that temperature is 0? Did you understand this? Because no random motion going on. યાદ આવ્યું ને? Earlier also we have studied that average translation kinetic energy is 3 by 2 kBT. If no random motion is going on, this is 0. That means temperature will also be 0. So this is a case where there is no internal energy. Make sense? If you see that everybody is stationary inside the bus, that is, they are not roaming here and there, then there is no internal energy. Clear or not clear? In this case here, these people, they are moving inside the system. It's like molecules moving here and there. So that has internal energy, right? And the more random motion there is, suppose અંદર બધા બસ એટલો જોશ આવી ગયો, એટલી મજા આવી ગઈ કે બધા ગાંડા થઈ ગયા, આમ 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 બધી જગ્યાએ ઉપર નીચે ભટકા ભટકા કરે. Okay, so that is what is lot of random motion, and that means there is more internal energy, right? Okay, so based on what we have studied so far, the random motion energy is nothing but internal energy, right? Whenever there is a system and there are particles or molecules or atoms moving here and there, right, their energy is what is internal energy. The symbol of internal energy that we use is U. Okay, right? What symbol do you use in chemistry? What symbol do you use in chemistry for internal energy? U. Okay, fine. So thankfully that is consistent. But yes, do not get confused between internal energy and potential energy. Do not get confused. Potential energy alog છે, internal energy alog hoy. So what would be internal energy? Okay, listen to this carefully. Suppose we write it for a monoatomic molecule. Let's say we start with monoatomic. U, U એટલે internal energy for one single molecule. Okay, for one single molecule, not for the whole gas, for one single molecule. Then what can a monoatomic thing do? It can only do translation. So do you agree that average internal energy for one single molecule will be just this, which is going to be 3/2 kBT? Yes or no? આ random motion ની જ energy છે ને. Okay, this is the energy of random motion, right? So here the internal energy is purely kinetic. You see what I'm saying? Here the internal energy is purely kinetic, and not only that, purely translational. Purely kinetic and purely translational for monoatomic. But instead of this, suppose you were to do this. Listen, suppose you were to do this for diatomic rigid. For diatomic rigid, again for one molecule only. પછી બીજું બધું સમજાવીશ, પહેલા ખાલી one molecule નું સમજી લો. Okay, so this will be equal to, હવે શું કરવાનું? You know, there is kinetic translation and there is also kinetic rotation. Do you understand what I'm saying? Because a diatomic rigid molecule will have rotational energy also. That's what we talked about, right? ગઈકાલે એવું કર્યું હતું, ગઈકાલે એટલે last time. So here, do you realize that if I want to write it, then there is 3/2 kBT for translation, same as this. Okay, there is one more way to explain it so far. See, translational degrees of freedom કેટલી છે? 3 degrees of freedom. Do you remember that? Translational degrees of freedom 3. So for each it is half kBT. આની પહેલાનો law, Equi Partition Law. For each it is half kBT. So for 3 degrees of freedom it is 3 into 1/2 kBT. Okay or not okay? This is clear? 1 માટે half, second માટે પાછું half, third માટે half, એટલે 3/2 kBT. Now just like that, do you realize that for rotation here I should write 2 into 1/2 kBT? Yes or no? Why 2 into 1/2 kBT? 2 degrees of freedom. So 2 into 1/2 kBT. So finally this becomes 5/2 kBT. Okay, this becomes 5/2 kBT. For what? For diatomic rigid. Similarly, can you tell me what will this be for diatomic and non-rigid for single molecule? Can you tell me that? Use your chart. Yes, it will be 7/2 kBT. Right? Why 7/2? You can explain it in different ways, right? One way is thinking of it like this. Okay, we'll get done very quickly. T, Kr and plus, then there is energy for vibration. So kinetic energy for vibration and potential energy for vibration, right? So this is 3, this is 2, this is 1 and 1, right? For vibration there are 2 total, right? So ultimately this would become 7/2 kBT. Okay, understood this? આ નો સમજાણું ને, મને એવું લાગે છે. કાઇનેટિક પોટેન્શિયલની ટર્મ્સ જો પાછી વાઇબ્રેશનમાં, એટલે તરત ખબર પડી જશે, બરાબર ને. એમાં એકમાં હાફ કે એક્સ સ્ક્વેર હોય અને બીજું હાફ એમ વી સ્ક્વેર ફોર વાઇબ્રેશન, એટલે એક કાઇનેટિક એક પોટેન્શિયલ, બે થઈ ગઈ ને. ઓર ડિરેક્ટલી ફ્રોમ ધ ચાર્ટ 7, રાઈટ. So 7 into 1 by 2 kBT. So that is what is internal energy for different molecules, right. In short, we end up with this final formula. Okay, bus last line for one molecule. F by 2 kBT. What is F? F means degrees of freedom. F means number of degrees of freedom. Understood this? थ्री आवे छे तो 3/2 આવ્યું. જો આમાં 3 હતું મોનોએટોમિકમાં, પછી ડાયાટોમિક રિજિડમાં 5 આવે તો 5/2 કેબીટી થાય. એવી રીતે આમાં 7/2 કેબીટી. ઇન શોર્ટ, F/2 કેબીટી always. For one molecule, internal energy. What is internal energy? It is F/2 kBT. આ એની ફોર્મ્યુલા છે, રાઈટ. અચ્છા, એક વસ્તુ અહીંયા છે ને, આઈડિયલ ગેસ લખ નાખો. ફોર વન મોલિક્યુલ ઓફ આઈડિયલ ગેસ, ફોર વન મોલિક્યુલ ઓફ આઈડિયલ ગેસ, F/2 kBT. Okay, so make sure you remember this. This is extremely important. Thermodynamics chapter માં આવશે, આમાં હજી આગળ આવશે. Okay, so with that we end the class. Goodbye.